We want to describe how our wave's moving, but to do that we need to know what are the important properties that need to be measured to describe the wave. You might recall back in the first module we had to figure out that position, velocity and acceleration were the important quantities to describe motion. What do we need to describe how our wave is moving? Well, let's have a look at a wave and see what things sort of shine out as measurable quantities. The wave we're going to use as our example will be a transverse wave on a string, because that's kind of an easy one to visualize. So let's have a look at our wave. It's here at the top of our screen and it's wobbling up and down and maybe moving across with speed v off to the right there. And what we're going to do is take a snapshot of that wave so we can see whereabouts it is at some particular point in time. And that's what the graph below is showing. The graph below is showing the wave moving up and down at some particular position. That's all happening at the same time. It's like a photograph of the wave. You can see it kind of looks the same as the wave on the string. Now, what you can notice in that wave is that it's very repetitive, that after some certain distance, you get the same shape of the wave occurring again. And so one thing that might describe that wave well is how far must you travel along the wave before you meet the same kind of wave. So let's imagine at the top here, this part of the wave looks pretty much like this part of the wave. So we could say the distance between those tells us something about the kind of wave we've got. We call that distance the wavelength, and we give it the Greek letter lambda as its symbol. So wavelength seems to be a nice property to describe our wave. We'll give it the symbol lambda, and we're going to measure that in units of meters. Now, any other two parts of the wave that are identical will also be separated by the same distance. So we could choose this point here, for example, and this point here, two identical parts of the wave. The distance between those points will also be a wavelength. So that's some spatial information about our wave now. What about the timing information? The wave's wobbling up and down as it goes along the string. What tells us about the timing of the wave? Well, instead of taking a snapshot of the wave, because we don't get any timing information from that, let's examine one part of the wave as it's moving. So we'll look at our wave now at the top here, again, still moving along with speed v. But now we'll imagine, let's zoom in on this particular part of the wave here and see what's happening there. As the wave passes, this thing's going to be going up and down and up and down. And the graph below here, although it looks similar to the one that we looked at previously, this is actually now showing the position of the wave as a function of time. And so what one particular location is doing. And again, what you see is this very repetitive nature of the wave. After some time, that piece of rope is doing the same motion. It's going up and down, and then it's going up and down again as the wave goes past. So it might be useful to determine what time does it take for that part of the rope to be doing the same motion. And again, you can see from this part of the wave here to this part of the wave here, this is a distance, a period of time, and we call that, in fact, the period capital T. So the period is the time it takes for some part of the wave to do exactly the same motion. We call it capital T. It'll be measured in units of time, that is seconds. Now, sometimes we don't want to know about the period so much, how long it takes for one cycle of the wave to go past. We might like to know how many times does that wave shape go past every second. That's how many waves per second. And we call that the frequency. So the frequency is going to tell us something about the timing, a little bit different to the period, but similar information. Frequency, we'll call it F, and it will have units of inverse time, which we will call hertz. And because these two bits of information, the period and the frequency, are really telling us just the timing of the wave, they actually turn out to be closely related. In fact, you can show very easily that the period T is simply 1 over the frequency F. They're the inverse of each other. So now we have some timing information, we have some spatial information from the wavelength. We can put those together to find out something about the way the wave is moving. So here we have our wave still moving across the top at speed v. Can we determine that speed? Well, yes we can, because we now know how far the wave has travelled. Remember, it travels along here one wavelength. How long does it take to do that? Well, it takes one period to do that. It travels one wavelength in one period. So we can find that the speed of the wave will be the distance that it travels, that is the wavelength, divided by the time it takes, distance over time. And remember the period there is 1 over the frequency, so quite easily we can rewrite this as the velocity of the wave, the speed of the wave, is the frequency times the wavelength. And this is a very useful relationship for all waves. It tells us how the speed depends upon the frequency and wavelength of the wave. Now, the only other thing from these graphs that might be useful to describe our wave is how big is the wave motion itself? How much up and down motion is there? And we can look at our graph here and say, well, it goes from up here to down here, for example. We can describe this as the amplitude, and we'll call that the letter A. It goes between plus and minus A. And of course, it's the same on this graph here. It's the same wave with the same motion. It's going up and down between A and minus A, and we call that capital A measurement there, the amplitude of the wave. So now we have these four measures of the wavelength, the frequency, the speed, and the amplitude. What we're going to do in the next topic is find a mathematical way of combining these to give a nice description of our wave.